Hello, hello. We are starting Unit 7, Lesson 1. Lots of geometry. Here we come. So this is Similar Figures Part 1. Recall that two figures are congruent if the figures have the same shape and the same size. In congruent figures, corresponding sides have the same length and corresponding angles have the same measure. The symbol for congruence is this equal sign that has a single sort of squiggle over the top, like a tilde in Spanish. So what we're saying is this angle here that has a single arc is the same size as this angle here with a single arc. So angle A is congruent to angle D, same size. Angle F, well, if you look at angle F, it has a double arc. And that double arc means it's congruent to the other double arc, which would be angle B. And then we've also got angle E. Angle E has the triple arc, and that one is the same measure as angle C that also has a triple arc. Then we've got side lengths or segments. So the segment AB, if we highlight that, you will notice that it has two tick marks, double tick marks. So we're going to look at the other triangle, and we're going to look for the side that has the double tick marks. That is side DF. Now you do have to be careful the order. It goes from A to B. Notice A had the single arc, B had the double arc. So when we name the other one, D has a single arc over to F with the double arc. And the symbol for segment across the top, meaning that it is only a certain length. It doesn't go on forever. Then we've got segment AC. Segment AC goes from a single arc to a triple arc, and it has one tick mark. So I'm going to look for the one tick mark, and I'm going to go from the single arc to the triple arc, which would be DE, and it's segment DE. So lots of little details on this. And last but not least is BC. B goes from the double arc to the triple, and it has a triple tick mark. And this one goes from double to the triple, F over to E with the triple tick mark. Write a congruent statement. So a congruent statement about the two triangles would be to say that triangle ABC is congruent to triangle. Now A was single arc, double arc, triple arc. So over here I'm going to go DFE. So I do have to name them in the same order. Two figures are similar if they have the same blank, but not necessarily the same blank. So these were congruent, meaning that I could turn one or I could flip one onto the other. Same size, same shape. Two figures are similar if they have the same shape, but not necessarily the same size. And this is what happens when we photocopy something and it either gets larger or smaller, but it maintains the same angles. All similar figures have the following two properties. All corresponding angles are equal. So we're saying that this single arc and this single arc, even though the triangle has changed size, the angles are still the same. This double arc and this double arc, even though the triangle has gotten bigger, the angle stays the same. And last but not least would be the triple arc on C is congruent to the triple arc on F. So according to that, angle A corresponds with angle D. They are in the same location. What do you notice about the angle measures? So corresponding angles are congruent. Now, the word corresponds does not have a symbol. You actually have to write out corresponds. What do you notice about the angle measures? Corresponding angles are congruent. And that was the same as when we had two lines that were crossed by a transversal. The corresponding angles were congruent. Here, the corresponding angles, the one that they're in the same location, they're still congruent. What side corresponds with BC? All right, so if we look at BC, it is the side with a 6, but that's not going to help me because I don't have any sides over here with a 6. BC goes from the double arc to the triple arc. So over here, EF goes from the double arc to the triple arc. So the corresponding side would be side EF. What side corresponds with DF? So DF, which is on the larger triangle, goes from single arc to triple arc. And on this one, AC goes from single arc to triple arc. Find the following ratios. So a ratio is a fraction. In this case, you'll see AB to DE. So side AB is 10 to side DE, which is 20. So we're saying what's the ratio from the small triangle to the large triangle? If I put that in lowest terms, it is 1/2. The small triangle is 1/2 the side length of the large triangle. BC, which is 6, compared to EF, which is 12. You'll notice that is also 1/2. And AC, which is 7, to DF, which is 14, also 1/2. So what do you notice about the ratios? Corresponding ratios are equal, right? If I pick corresponding sides, AC to DF, you'll see they're both purple. Those corresponding sides, 7 to 14, is 1/2. That is equal to a 10 to 20 ratio or a 6 to 12 ratio. Are the two triangles similar? We would say yes. How do you know? Angles are equal. That was number 1 here. All corresponding angles are equal. We've got a single, double, triple arc that matches up with a single, double, triple arc. And the ratios of corresponding sides are equal. And side lengths are proportional. And that means that I could do a 10 to 20 equal to a 6 to 12 because they're both worth 1/2. Or I could do a 10 to 20 equal to a 7 over 14 because they're both equal 1/2. Write a statement of similarity. So here we're not saying that these two triangles are exactly the same. We're saying they're similar. So we would say, for example, triangle ABC is similar to triangle DEF. Now you will notice a new symbol here, the single squiggle mark that does not have the equal. That is the symbol for similar. So triangle ABC is similar to triangle DEF. Now, if you look at the second page for the notes here, we're going to start talking about the measure of the angles. Before we were just saying they're congruent or they're equal. Well, if we talk about the measure of the angles, you'll notice this little lowercase m. So the measure of angle C equals the measure of some other angle. So how are we going to know? We're going to look at this name here that was given to the two quadrilaterals. Now, I know they're quadrilaterals because they are each represented by 4 letters. I know that they named A first and they named E first. That makes those corresponding. That makes them congruent. Angle B is listed second with angle F. Angle C is listed third, which means the measure of angle C is going to equal the third one over here, the measure of angle G. The measure of angle H, which is listed last, is going to be equal to the measure of angle D, which is also listed last. Now here in this next part, we're looking for a pattern. BC compared to FG. So BC are the 2 middle letters compared to FG, which are also the 2 middle letters. So that set up a pattern. We listed the first one, then we listed the second one. Here, what is in the same location as GH? So from this first quadrilateral, what 2 letters are in the same location as GH, which are the last 2 letters? We'd have to go with CD. All right, this one's a little trickier because we have to look for a pattern. Notice AD is on the bottom, which means the first one is on the bottom. EF is on the top. EF comes from the second named quadrilateral. So EF is in the same location as AB. So EF and AB are corresponding over here. What is in the same location as AD? A is the first letter, D is the last letter. So it's in the same location as E is the first letter, H is the last letter. So it's all about looking for patterns. Are the two triangles in the figure below similar? Well, let's start breaking it down. In order for them to be similar, first, they need to have 3 congruent angles. So I have a 30 degree and a 30 degree. I also have a 60 degree with a 60 degree. And last but not least, they both have a right angle. So first of all, they have 3 congruent angles. Because they have 3 congruent angles, we can say yes, 3 pairs of congruent angles. And you're going to say, Mrs. Fraser, we don't know if they're similar because we can't see any tick marks on the sides. This side is not the same length as this side. I can tell, but I can't do one of those proportions. Well, what's interesting is for triangles only, if the angle measures are equal, then the triangles are similar. You don't actually have to verify the ratios of the side lengths. Now, one more time, I'm going to say it one more time. This is for triangles only. If you have more than 3 sides, then you have to prove the sides are proportional as well. Write a similarity statement for the two triangles. Let's name this one X, Y, Z. Doesn't matter which one you name first. I happened to name the larger one on the right first. It is similar to X has the 30 degrees. So I'm going to start with triangle B, 30 degrees. I went down to Y, which was the 60 degrees. So I'm going to name D second. And then I went over to the right angle Z. So I'm going to name C last. And one of those funky tongue twister sort of puzzles, all congruent figures are also considered similar. If they're congruent, we know they have identical sides and identical angles. So that also qualifies them as being similar. But not all similar figures are congruent. For example, these two are similar, but they're not congruent. Whereas over here, if I drew you two squares that are congruent, you could be like, well, are they similar? Sure. They have all the sides the same length and all of the angles are the same measure. That makes them similar. It also makes them congruent. But if I do two similar figures, like the two triangles directly above, they are similar only and not also congruent.